Okay, so in this video, we'll be discussing transformation. And actually here, this discussion here will be already the summary of transformation. So we have four. We have translation, we have reflection, rotation, and dilation. Okay, so let's try to go first with our translation. Okay, translation actually can be illustrated on this figure here. We have this one here. Okay, so the blue one here is our what? Free image. When you say free image, that's the original image or original figure. And then the red one is our image. And when you say image, that's our result. So in translation, what do we do? We're just trying to what? Change the location of the figure. So on this illustration, initially it's on this left side, the blue one, and then we move it to the right. So our key term for translation would be what? We have the word sliding, or it's like we're just sliding the figure, or moving. That's it. So we didn't really do much in translation. We just move the figure. And take note that the movement of the figure would be what? All the coordinates would be same direction and same distance. And actually, we can use this one here, the algebraic representation of translation below. So okay, we have the x comma y, and then we have the arrow here. It's the symbol for transformation. And then we have x plus a, and then y plus b. So the a and b here is not always plus, huh? So it would depend on the given. So let's say, for example, we have here x comma y, and then our transformation or the translation would be x plus 2 and then y plus 4. Sir, what does it mean by x plus 2 and y minus 4? Okay, I want you to please take note that with regards to translation, remember that the direction of our or the orientation of our y-axis is the horizontal line. So what's our direction here? The horizontal line. We have what? We have left and right. Do you agree with me? Left and right. So that's our x-axis. So the x-axis will tell you whether you're going to left or to the right. Okay? Now, comparing now it with our y-axis, take note that with regards to y-axis, it's the vertical line, right? The y-axis. So our y-axis now will tell us the direction of up or down. Okay? So let's say, for example, we have x plus 2 and then y minus 4. So since x is plus 2, so it's plus positive, right? It's going to the right side. So we will move the figure 2 units to the right. And then the y minus 4 would mean, since it's minus 4, we have to go down how many units? 4 units down. Okay, now what about we have x minus 5? So it says minus 5 and then it's the x-axis. So we have to go where? We have to go left 5 units. And then the last one, the y plus 3, that would mean what? Again, the y-axis is up or down. So it's gonna be 3 units up because it's positive. Okay? I hope this one is clear. Now let's go with reflection. By the way, I'm so sorry with my kappa. From time to time, I might make some unnecessary noise. I'm sorry. Now, let's go with reflection. So reflection is kind of actually familiar with you already because reflection is like the idea of mirroring something. So that's why actually we have this one here. It's our pre-image, the blue one, and then our image, the red one here. So let's say our line of reflection is here somewhere in the middle. So it's like you're trying to get the mirrored figure or the, res- the result of a certain figure after you mirror it. So our key term or the keyword for reflection would be what? We're like mirroring, mirroring, or what? What else do we do? It's also like we're trying to flip the figure, right? We're flipping the figure. Okay, but that would depend on the direction or the line of reflection. Okay, please take note that we have two line of reflection that could be possibly used. We have the y-axis and then x-axis. Okay, I'm sorry for that. Most of the time it could be x or y-axis, but at some point in your advanced mathematics, it could be not only the x and y-axis. But for the meantime, we'll just use x and y-axis. Now let's try to understand this one here. It says x comma y, and then transformation, or sorry, reflection of negative x comma y. So what happened here is initially the x is let's say our given here is 5 comma 2, and then it says the x will become negative, so it's gonna be negative 5 comma 2. So that's how you will do it. I mean, how you will translate it. Sorry, that's how you will do the reflection. So it's since the since in this given here, it's the x value that changed its sign. Our line of reflection, take note, is the y-axis. And actually, we can confirm that one when we try to illustrate it. Actually, after this video, we'll be having problem solving involving transformation. Now, what if it's already the y that we change the sign? It's gonna be a reflection across the x-axis. Actually, I guess I could already keep on repeating this one during class. So I hope this one is already kind of familiar with you. But to further understand this one, we will explain it during our problem solving the next video. Now, after reflection, we have rotation. Okay, and in rotation actually, we have two ways of doing the rotation. Okay, so the first thing is actually we can use this table here. We can use this table. This one actually, my advice if please try to familiarize with this rule. Okay, and in rotation here, usually our center of rotation is the point of origin or the 0 comma 0. However, in your higher mathematics, at some point you will use a different center of rotation already. But for the meantime, let's just try to use the point of origin. And sir, what's the other thing you're mentioning about other way? Because a while ago you mentioned there are two ways. And actually, the other way would is like you're trying to imagine how would the figure look like. And later on in our next video regarding the problem solving of transformation, I will mention about that one, okay? But again, please in rotation, we have to follow this rule, okay? This rule here. But then how do we use this one again? Okay, for example, we have here, one of the coordinates says 1 comma 2. And then the question says, rotate the figure 90 degrees clockwise. What's the rule? It's gonna be what? It's gonna be y comma negative x. So what's the value of our y initially? Our y is 2. So, and then it will become negative x. What's the value of x a while ago? 1. Negative 1. So, when you try to rotate the figure initially, let's say the coordinate is 1 comma 2, it will become 2 comma negative 1. Let's say another coordinate is 5 comma 3. And then it says you have to rotate the figure again. Same thing. Rotation of 90 degrees clockwise. What's the rule? Y comma negative x. So, let's say we have here. So, our y is 3. And then it's going to be negative x. So, negative 5. Okay, maybe one more time. What about we have like negative 4, comma, negative 3. What about that one, sir? Okay, get first the y. What's the value of our y? Again, I take the rule. Take the rule of y comma negative x. Let's say we will do again a rotation of 90 degrees clockwise. So you get first the y. What's the value of y? Negative 3. And then it says negative x, but our x here, sir, is negative 4. Don't be confused, huh? X here is already negative 4, and then you will get the negative sign or the opposite sign. So negative 4 will become positive 4 because it's gonna be negative negative. Do you get that? Maybe one more time. What about we have um, negative 5 comma 2, and then same thing. You will do rotation of 90 degrees clockwise. What's the rule? Y comma negative x. So you get the y. What's the value of our y here? It's 2. And then what's the value of our x? It's negative 5, right? But we will get the negative sign. So negative of negative 5 or negative negative 5 is going to be positive 5. So when you try to rotate this point here, and then you will do rotation of 90 degrees clockwise, it's going to be 2 comma 5. We will further explain this one as we go through our problem solving or illustration of rotation. Okay? Now, let's go with dilation. This one actually, okay. The letter K here. Okay, by the way. So when you say dilation, sir, what do we do in dilation? Okay, take note, ha. that dilation is actually the what do you call this one? The most different among the four because translation, reflection, rotation, they belong to rigid transformation, right? When you say again, say rigid, when you say rigid, that means we do not alter the size or the shape. However, for dilation, it's different in a way that it's a type of non-rigid transformation. When we say non-rigid or similarity transformation, we actually alter the size or we change the size. However, the figure or let's say the shape, it's still the same thing. Let's say example, you have a triangle. Once you dilate it, it's still a triangle. However, it's only the size that will change. So, in terms of dilation, we're like trying to enlarge or reduce the size. Okay. So our key term for dilation is like enlarging or um, reducing the size. So how do we enlarge or reduce the size? We use what? We use our scale factor, okay? I hope you can still remember about the scale factor. Our scale factor tells us whether we're trying to enlarge or reduce the figure. So what do you mean by that? So let's say for example, our scale factor is more than 1. Again, please take note. Once our scale factor, excuse me, is more than 1, it means to say we're trying to enlarge. We're trying to enlarge the figure. However, let's say our figure, or sorry, our scale factor is less than 1, but greater than 0. Okay, I will just put here SF. This means scale factor. Again, one more time. Let's say our scale factor is greater than 0. For example, we have 0 0.1, 0 0.2, 0 0.3, but less than 1. Again, less than 1. It's what? We're trying to reduce the figure. We're reducing the size of the figure. Okay, please take note of that. Now, let's say for example, we have here our illustration, x comma y, and then the transformation says 2x and 2y. So the 2 here, again, this would be common here. The 2 here would means the scale factor. And again, once our scale factor is more than 1, we're trying to enlarge the figure. So what if it's 1 half? So let's say x comma y, and then it becomes 1 half x comma 1 half y. So we're trying to what? Reduce the figure using a scale factor of 1 half. Again, example of more than 1, enlarging, we have 2, 3, 1.1, 1.2, 1.3, so more than 1. However, if it's the scale factor is more than 0 but less than 1, it's reducing. Sir, why greater than 0? Can we include negative numbers? Actually, no. Because it's like in reality, right? How can you scale or how can you do we scale or do we like make something bigger using a scale factor of negative number? Because here we're actually dealing with measurements. And regarding measurement, most especially if it's like distance or length, we don't actually involve here negative numbers. Please take note of that. And the last example here, we have the um, x comma y and then 3x comma 3y. So our scale factor is 3. Again, these numbers here should be common. Okay? So this is the summary of transformations.